This is Sujit Mahajan from Pulchowk Engineering Campus. I'm a master student of knowledge engineering, and today I'm gonna present on information extraction. So let's get started. Before information extraction, I think we should actually do information gathering. So this is the slide that was presented in my class. So I'm gonna explain the whole information gathering and knowledge acquisition process in knowledge engineering. So let's get started. So information, the whole process of information consists of four distinct uh, stages, and all these stages define or explain what is the actual health of a society, right? So someone will use or create some kind of information, and they may decide to publish them, and those published or stored gets shared in the society, and someone who may be interested in solving some a similar kind of problem will collect those information, use them, and may do some improvement on this, and may decide to publish and share, and thus the cycle of information growth, mushroom growth of information continues. So this is the information cycle, right? The information can only be created based on existing information, right? So no information can be created out of information. Collect, use, or create, use and create, right? So when we if we want to invent a new theory in physics, right, or if we want to uh, do anything, right, you need to first learn what others in the society have already developed or already known facts or known methods used uh, in solving that particular problem, and maybe you will just try something out and find the better way and share that thing, right? So that's how knowledge grows in our society. So value of information is how much it is used, right? So no value for transfer information without use. So any information, right, if it can be put to the use, it is valuable. So for example, uh, we have a lot of theories in science, but only those theories which can properly explain this world and can be used in other aspects of day to day, in predicting other aspect of this world, are actually useful, right? It doesn't really matter whether there is an uh, whether uh, whether whether there is actual time dilation, or it's just our perception, right? When we move in the space in the speed of light, or close to the speed of light, right? but uh, but what matters is that we will feel that we may not we may feel like the process of time is passing at same rate for the person that is moving at the speed of light, but For a stationary uh, person who will be seeing our action, his experience of speed of time will be different, right? So there are many theories, like theories of gravitational pull and the Einstein theory of gravity graph space and time. But uh, when they try to explain the other scenarios, when they are used to explain the other uh, predict some other scenarios, right? They actually become useful. Uh, so using ability to use it creates the value of the information, right? So accumulation of information is the wealth of society, right? So distribution of information is the health of society. So if we think in this way, right, because the society can, uh, unlike an individual, which can act immediately, society uh, may may face some delay, response delay, right? So if there was some kind of pandemic, and if the information of those the new diseases spreaded faster, the society could act faster, and therefore its health, and it can actually grow its information at faster rate, grow its knowledge at faster rate. So accumulation of information is the wealth of society. So public share and collect is actually related to distribution of information, and that is really important aspect of um, knowledge engineering, right? So information gathering can be done, right, from I think browsing and published contents, uh, or from filtering or recommendation, or asking them to rank, uh, by asking people to rank, think, explore their priority, right? And information using the information can be published from by clustering, classification, extraction, and mashup, right? So these are the steps that could be used to transit from one stage to another stage, right? So information gathering. So relationship between agents and information source, right? So agent is the person that consumes the information, and so main task how to provide access to agent to information stores, information gathering, right? So we are like an agent, and information stores are like expert. So how can we gather the information from them? So there are many methods for information gathering, and as a knowledge engineer, you have to go to the expert and try to understand, or try to model the knowledge and information he uses to carry out an expert task and build a KBS, right? So information retrieval is an explicit specification of user's need. Browsing, implicit specification of username, and finding it by yourself, right? Information filtering and reconcile, implicit specification of username, guessing users preferences, right? Ranking based search, explicit specification of username plus general preferences. So this is how we can gather finding information on the web. We could like use like search engines, web directory, web portals, auto recommendation systems, social, and also social recommendation to find the information that we need. So in terms of world wide web is can be uh, can be uh, viewed as something like a spider web, in which there are hyperlinks that point from one side to another side, and forming this great chain of documents interrelated documents, right? So we can also crawl the web. Crawling the web refers to uh, using those hyperlinks to hop between different pages, uh, and they are usually drawn by special programs called crawlers or spiders, and they are also called robots, right? So robots, they bots, they crawl them, and they gather the information. So Google is one kind of such robots that that crawls the web and index the web and help us find information on the web quicker by indexing the whole web. So the process of information retrieval, right? So there is a person that uh, generates a document, and there is some those documents are somehow indexed. Index is nothing but a process of making it easier for information retrieval. So, an IR system will actually get input as a source result, right? And all the documents that it receives will store it in an represent index representation, and it actually when the source request is received, uh, it analyze that source request as a query and try to match the proper index, the proper that try to match the proper documentation that he information system is information IR system information retrieval system is things that the user is asking for, and based on that math, it retrieves the document and presents it to user, right? So indexing web pages, the index of the so indexing web pages may like indexing the contents of each web pages, and for that we may have to do something like strip tags, tokenize or segment the words the sentences that or the paragraph that people are using in this, removes stop words, and maybe stemming refers to the uh, finding out the root of the word. And also we need to process some metadata tag, right, which may have some keywords, contents, author, etc, right? So although I think the keywords are now not used by Google and other search engine, because people were spanning the site with the keywords meta tag, but that can also serve as um, a primary source of information, right, when we are crawling the web. So ranking sources, we can rank the source results as per the relevance of each document to source query, right? We can use either vector space model, or language model uh, to find whether that document is similar to what we think the source query is searching for, right? And also there is a famous page rank algorithm from Google, which page ranking system by Google, which like um, whose main idea is that when a site is being cited or linked in any document, it is the document its citing is actually more important, right? So based on that, it provides the gives us the relevant, the most relevant document that a internet user is currently searching on, and that process has given rise to a tech giant Google. So ranking is like sort the content by some criteria, right? We need to somehow say that the document is this document, X document is better matched to query, or Y document is better matched to query. So that can be the process of finding which one is better matched is through the process of ranking. So relativeness to the given keyword. So we can use something like term frequency or inverse TDIDF. In NLP, metadata full text are only using for using the keywords, and also there is also something like the importance, reliability, and credibility, which could be from the page Google's like page rank algorithm, or the hits, how much hits a site has gotten, right? Also, it could be the how much citation score for the research paper. So this is the way of finding out the ranking of the science. So TF-IDF is one of the important measure of importance of T within the document. Set T by word T, right? So if we have a word T in document D, in all the documents set D. So and TF-IDF is one kind of measuring the measuring the importance of the use as used to find the similarity between documents. And so TF term frequency DT refers to the frequency of word T in document D. IDF-TT refers to the number log of a number of total documents in the state, and